Hi, Daniel Tokar here from the Willow Forge in Shepherdstown, West Virginia. And today we're going to continue with the Blacksmith Dictionary by getting into threads and the tools that make threads. You say, well, that's pretty common. Everybody's got that stuff in their shop. And just to show you, we have a modern machine die and a modern tap. And keep in mind as we go along the shape of that tap. Okay? So, in the 18th century, blacksmiths had to make their own tooling. The taps and dies for making their own nuts and bolts and machine screws. And it's why there is very little standardization, because every blacksmith or gunsmith made the tools that he needed for his own work. There were some professional tool makers that made things that were standard to their standard, but there were no national or international standards. And even the large arsenals like the British Admiralty had standards fairly early on. They're not standards as we would know them. They did not have a precise thread form or size standard or number of threads per inch for a long time. They had very broad and general standards, and it's why there was no real interchangeability of parts. You couldn't take a Brown Bess musket apart and just interchange parts. They were all made to slightly different sizes and tolerances and standards. So anyway, this is an 18th century hand-forged tap. That's like a gunsmith's breech tap for threading the barrel of something like a flintlock rifle. And you'll notice that it's triangular and it has no cuts. The flats are just that, they're flats. It's got a rectangular shank, and it has a taper from the front to the back. And this was done cold. I've heard some people express the opinion that these tools were meant to form threads hot, but I don't believe so. I think that what really happened was as you started the tap, and as it drew itself in, it pushed the threads into the soft iron, because these were really designed for things like soft iron rifle barrels. And as it went deeper, it cut it deeper as it drew into the taper. And the thread form is sort of a rounded V. You'll see on the white board in the vise that I have kind of an exaggerated thread form, which is sort of rounded, sinusoidal shaped threads, and the lower one is the more modern 60-degree pyramid shaped threads that everybody's familiar with. Well, very early on, screws had a very rounded profile. So if you see an 18th century machine screw, it will have a thread form. I'm trying to get that lined up with the whiteboard. That is an 18th century typical style thread form. A very rounded, it's almost as if you took a wire and wrapped it around the rod. And this is not something that's easy to cut. They were thread formed mostly. I believe most screw threads were made with taps that tapered enough so that they would draw in and actually push the metal around, because it was soft iron. Now, there are some taps that have cuts in them. That's also a tap for cutting sort of rounded thread forms. But as often, you'll see taps that again have no cuts, no cutting edge at all. That is a tap designed to basically roll that thread form into a soft iron nut. And it's also nothing like a V-shaped. It's a very rounded thread form, and it tapers in the whole tap. So if you were running that into a nut, because there are not necessarily standardized sizes for fasteners, even somebody making a wagon in his own shop is not necessarily going to worry a whole lot whether the nuts interchange between different parts of even the same wagon. So he would make a nut by punching a hole that was more or less the starting size of this tap. I'll hold it up against the whiteboard. And then when it was cold, he would thread that in as far as he thought he needed to match a particular bolt, a particular machine screw. So even the same blacksmith using the same tools was not necessarily making interchangeable parts. I have seen nuts that do not fit the other threaded screws on the same wagon. It's possible. Anyway, the tap has a mate. This is a die plate. You can see that actually threads into that one. And you'll notice this is again a blacksmith-made 18th century die plate, probably for gunsmithing, for making things like breech plugs. It has a hard steel center section with a wrought iron pair of handles that's forged around it because the steel was valuable. You can see the forge weld line along in the center there. And you'll also notice that each one of those holes is a slightly different diameter, even though it has the exact same thread pitch. You could actually start out with the larger one and then jump to the next smallest one to make it a little bit smaller. If you couldn't get the male and the female parts of the thread to mate up, you would just go to the next smallest hole and continue until you got them to match. So again, this is a case of you can't point to one of these holes and say that this is a 5/8 inch by whatever thread, because that wasn't a concept they really had. They wanted it to be snug and to be tight, and if they had to go to a slightly smaller hole, and this is why you can actually find things like 11/32 by 11 thread per inch screws with matching nuts on old equipment. It's why old gunsmithing can be a real adventure, because you end up with very odd sizes. So again, that is the 18th century version of a tap and die. Now, a little later on, early 19th century, they started making taps. That's a long tapered tap that still have that same concept as the 18th century tap, that there is not a cutting edge per se on that. If you look at that, that is just a forged tapered square with threads, and the threads are still not quite 60-degree modern threads. They're slightly rounded, and there is a definite taper to that whole tap. And again, it's kind of like with modern pipe dies and taps, that a tap like this was probably being used on something like a steam engine or a water fitting. And what was important was that they would get it to be a gas-tight, a steam-tight, water-tight fit. So they would just tap the hole and then try the fitting or the fastener. And if they needed to make it a little bigger or a little deeper, they would just go back and run the tap in a little further until they got a mating set that worked. So you can imagine how maddening it was to try and supply something like a locomotive in that era when you couldn't just go to a box and take a fitting out and be assured that it would actually come up tight. This is also when there were proprietary thread forms and proprietary thread shapes and proprietary pitches, so that if you got a fitting or a fastener from one company, it didn't necessarily have, even if it was something like a half-inch 12, a half-inch diameter by 12 threads per inch, that didn't mean you could actually thread it on another company's half-inch by 12 nut, because that company might be producing it with a sinusoidal, a rounded thread form, whereas another company might be using a pyramid thread form. And this stumbled along through the early part of the 19th century until they ran into real problems like the Civil War, where they needed to have many manufacturers produce interchangeable parts for lots of equipment. The logistical and supply chain for a big army would just about be impossible if you didn't standardize. So the English also had this revelation, and Mr. Whitworth, the famous machinist that invented the Whitworth rifle and a bunch of other things, invented a standard thread form called Whitworth threads that had a 55-degree pitch thread. The pyramid on the thread form was 55 degrees. The modern thread form is 60 degrees with a tiny platform on it. So that led to this generation of tool. This is a mid-19th century die for making machine screws for, again, something like a musket or other firearm. And you'll notice that this is the first tool that we have that actually has numbers on it, that you'll see that up at the top there it says number 1, 2, 3, 4, descending along the right-hand side there. And there are multiple die slots. They're starting to actually cut threads into standardized stock, with the cutting edges being those slots on the top and bottom of the threaded hole. And they still have to worry about in-between sizes, so that on a die plate like this, you might have something like a number 9 screw, but you also have that, which is like a 9.5, and that is a 10. So you have an 8, an 8.5, a 9, a 9.5, and a 10. Because standardization was still kind of loose, so you could hunt and peck until you found something that fit. That's also why tools like this came into vogue in the mid-19th century. That is a die that has movable jaws. I'm going to move those. And multiple pitches. And you have this adjustment screw as the handle that would bring it up tight, that when you thread that handle in, it pushes the die blocks together and brings it up tight. So if you see on this particular example, there are numbers on each of those die blocks, like 14, 12, so that's 12 threads per inch on that, 14 there and 14 there. But because these blocks are adjustable, you could still hunt around for odd sizes of thread diameters and pitches. With a tool like this, it's entirely possible to make a 5/16 by 12, a 3/8 by 12, a 7/16 by 12, a 1/2 inch by 12, a 9/16 by 12, and a 5/8 by 12 with the same tool, because you have enough throat to the tool to open this up and cut that kind of thread. So if you have enough of these tools, and here I'm going to give you a little bit of dizziness as I swing this around to show you on the bench here, part of my collection of such tools. If you have a set of those tools with different thread pitches, it became possible to kind of make whatever you needed to for different machine thread standards. So if one steam engine company was making something like a 1/2 inch 12 bolt, you could make a 1/2 inch 12 bolt. If you needed to have a 1/2 inch 14 bolt, well, you could make a 1/2 inch 14. And you could use that same 14 pitch tool to make something else, like a 3/8 by 14. So all those weird non-standard sizes by modern eyes could be made using a smaller number of tools than you'd imagine. All you need is to have a tool that has the right pitch and is adjustable enough in the size stock that it can use. So anyway, this is the Blacksmith Dictionary for today. It may not be a great revelation, but I hope it gives you an insight into the history and why some things get used the way they do. If you don't have standardization, you have to have tools that have more flexibility. Anyway, bye.